Chip manufacturing. Some key points discussed in the video about semiconductor chip production are: researchers and developers use scanning electron microscopes to check the chips at different points in the production process. Testing is done at every step in the fabrication of fully packaged power semiconductors. Chips are made up of billions of integrated and connected transistors. Quality control is essential at every stage of the workflow. The final stage of fabrication is assembly, where individual chips are placed in a package and terminals are attached. The fabrication process may involve repeating individual steps multiple times. Clean room production areas have strict dress codes and access restrictions. The process of manufactured chips from a wafer starts with the layout and design phase. Special design tools are used to draw up the plans for integrated circuits. The wafers is oxidized and exposed to light through a photomask. And lastly, silicon is a semiconductor and impurity atoms are added to conduct electricity. The next video that we have is entitled, "Why Making Chips is So Hard?" The content provides several insights into the workings and challenges of the chip industry. Firstly, the industry is typically outsourced to hundreds of different companies, with specialization in 5 distinct domains. Chip companies focus on chip design, while fabrication is commonly done by specialized contract manufacturers. Secondly, there is a growing trend of Microsoft companies designing their own chips to meet specialized workloads. Thirdly, there are economic and political tensions, with the US and Europe concerned about relying on foreign companies for chip manufacturing. China is also investing heavily in semiconductors to establish itself as a major player. Lastly, the cost of chip manufacturing is high, leading to the outsourcing of fabrication to specialized contract manufacturers. This approach allows companies to share resources and access cutting-edge technology. Next in line is the video entitled Photolithography. The content provided discusses various aspects of the photolithography process used in the fabrication of microelectronics. It explains how light sources, numerical aperture, index of refraction, and the max half angle of collimated light are used to approximate the numerical aperture. It also mentions the use of silicon wafer, photoresist, masking film, and chemical agents in the process. It mentions the companies ASML and Sokudo as manufacturers of photolithography equipment. Overall, the content provides a comprehensive overview of the photolithography process used in the production for microelectronics. The step-by-step process of photolithography involves the following stages. First is cleaning. The silicon wafer is treated chemically to remove any contaminations. Second is spin coating. Photoresist is dispensed onto the wafer and spun rapidly to produce a uniformly thick layer. Third is soft bake. The coated wafer is pre-baked to drive off excess photoresist. Fourth is mask alignment. A mask resembling the chip's geometry is aligned and placed above the photo-coated wafer. Fifth is exposure. UV light is directed through the mask onto the wafer, causing a chemical change in the exposed photoresist. Sixth is development. The resist is washed away in certain areas, depending on the type of resist used. Seventh is etching. A chemical agent removes the uppermost layer of the substrate in the unprotected areas. 7 is stripping. The remaining photoresist is chemically altered and removed from the substrate. 10 is cleaning and inspection. The wafer is cleaned and inspected for any defects. And lastly, repeat. The process is repeated for each necessary layer to complete the chip's circuit design. The fourth video that I'm going to reflect is how a CPU is made. The content provided is about the manufacturing process of semiconductors, specifically silicon. It highlights the importance of clean rooms, the doping of silicon with emplacement of dopant atoms, the collaboration of experts in designing integrated circuits, the use of hermetically sealed containers for transporting wafers, the dominance of copper in the production lines, the spin coating of silicon disks, the drawing of monocrystals from purified silicon melt, and many more. The content also mentions the nanocosmos of atoms and the small spacers required for manufacturing. The steps involved in manufacturing a CPU is as follows. First is monocrystal is drawn from purified silicon melt to create a perfect silicon lattice. Second is photolithographic techniques transfer the circuit structures to the wafers. Cleaning is essential to remove particles from the wafers. Fourth is integrated circuits are made by linking up billions of separated transistors. Fifth, the chips are cut off the wafer and bonded to a frame using the flip chip method. Lastly, the chips are packaged for final production. And the last video that we have is entitled 10 Top 10 Technologies to Learn in 2024. The content includes information about various technologies and their importance in career advancement. First in line is blockchain. Blockchain technology is gaining traction in various industries from finance to supply chain management. Next is augmented reality and virtual reality, or AR and VR. AR and VR technologies are taking immersive experiences to the next level, revolutionizing industries such as gaming, education, and medical training. Third is IoT, or Internet of Things. IoT is considered one of the top 10 technologies to learn in 2024 because it enables everyday objects to connect to the internet, making them smart and capable of sharing data. Fourth is 5G technology. 5G technology will pave the way for advancements in autonomous vehicles, telemedicine, and more. Fifth is machine learning. Machine learning algorithms learn from data and make predictions or decisions without explicit programming. Next is cybersecurity. With the increasing number of cyber threats, cybersecurity professionals are in high demand. Next is edge computing. Edge computing, this reduces latency and improves real-time processing. 8. Biotechnology. Advancements in biotech are transforming healthcare, agriculture, and more. 9th is quantum computing. Quantum computing has the potential to revolutionize industries like cryptography and drug discovery. And for the top technology that we need to learn in 2024 is the artificial intelligence, or AI. AI is reshaping industries with its ability to analyze and make intelligent decisions.